All right, good morning, my scholars. We're gonna go ahead and hop into lesson 10 summary, which can be found on page 135. And what I'm gonna do here is pretty much, if I can show you here, utilize the summary a bit more as we move through these lessons. I feel this is gonna be a great tool for you to it's gonna sound funny. Just summarize everything that occurred in class. I know sometimes we might miss a point or two because we have to look off screen to answer the phone, answer the door, whatever. But I'm telling you, these summaries are invaluable in your learning. And let's suppose that you actually did look at everything in class, you understood it very well. The summary is a nice, great way of condensing all the notes. So you could technically think of this as the notes already made for you for each specific lesson. Now, where can you find the summaries? So let's assume for lesson 10 here, which is titled multiplicity, you would go, this is activity 1, activity 2 is off here, off camera a little bit, then activity 3, and then summary. You will see that the summary is always located at the end of each section. So let's jump into, this is a really lengthy summary. I'll go into it in a bit, but, and then you have the practice problems, which I will be assigning. Okay, so let's hop into lesson 10. You got activity 1, 2, 3, and then you have your summary at the end here again for lesson 11, practice problems, okay? Sorry if I'm spending time here going over the book, but I did have some questions about like, where do I find this? Where do I find that? So just kind of refreshing my class. So here's activity 1 for lesson 12. Activity 2, you see how they're numbered. Activity 3 is lesson 12. Activity 3, so it's 12.3. We go a little further, and then you'll find your summary down here. And then the practice problems, right? Now the cooldowns are not included in the book, unfortunately, but those will always be available to you through the Google Quiz format, which we have already grown comfortable with, so that shouldn't be an issue accessing that if you've been doing it. Now, if you have not been active last semester and you're saying, hey, let's get this done, definitely check in with me, email me, say, hey, where do I find this? Where do I find that? I don't want anyone floating through the semester wondering or doing guesswork as to where things are located. Don't be shy. Ask this guy. All right, enough of that. Now let's actually hop into the actual summary. So I'm actually gonna hop into the text where it says, earlier we learned to identify the zeros of a polynomial function from the factored expression. So this is where I'm reading from. You can read this for yourself, okay? So once again, you can pause the video, read it for yourself. You have control over time and space here. So when I get down here, just because I don't read everything with you, doesn't mean it should not have been read, right? Read it, and then I will explain it. And then once I'm done here, I'll let you know, hey, pause it, read this section, then I'll explain it, right? So my explanations, you can pause at any point before I get to them. So you have as much time as you need to read every single section, okay? I don't ever want you to feel like I'm rushing you through the reading or forcing you to read at a certain pace, but rather when you're done reading that, once you hit play, you have a great set of information and tools at your disposal. All right, so this part here talks about what we did last lesson. So with this equation, we learned about zeros. And we learned that you can find the zeros of this equation simply by changing the sign inside the parentheses. Now, you won't always be able to do this easily because sometimes you have fractions and that just kind of throws things out of whack. Fortunately, we won't see those right now, but when they do, don't worry, I'll make sure I show you how to get these the right way. Right now, we'll use the shortcut of simply switching the signs. You will notice that the positive one, I'm not writing the positive in front of it, it's assumed. Okay, so then when you look at that graph, if you actually circle those points on the graph, 3 is right here, 1 was right there, and 4 is right there. Okay, that's a refresher on zeros. But then what they want you to learn, because remember, if you go back to the title of this lesson, it was called multiplicity. Remember, I do these videos in one take, so if I misspell that, I'm sorry, but I think I got it. We will see that the multiplicity of each of these quantities is 1. So the exponent is 1. And if you need to write this down in your notes, or you can even label here as we're going through it, you can label it here. You can label it on the side. However you wish to take the notes, that's fine with you. So if there is no exponent outside the parentheses, we can say the multiplicity is 1. Okay, here are some other numbers which have, or quantities I should say, that have no exponent visible. So x is the same as x to the 1. The quantity x minus 11 is the same as x minus 11 to the first power, and 5 is the same as 5 to the first power. So the multiplicity is 1 for each of those. So we say that each factor, x plus 3, x minus 1, and x minus 4, each have a multiplicity of 1. So what does that mean for us? So if the multiplicity is 1 here, well, if you remember, degree 1 is linear. So you're going to notice it's like a line right there, a line there, and a line there. The shape of it is linear at that point. So here it's linear, here it's linear. And you're probably asking yourself, Mister, it looks kind of curvy. Yeah, this line will lead into a curve. This line right here where it's flat will lead into a curve. So watch this. Look at this line, look at this line. I can connect them with the curve there, okay? So we say they're linear. So if the multiplicity is 1, that part is going to be linear where it crosses the graph. All right, so this leads us to our next point, which is on the next page, page 136. So what happens when the multiplicity is 2? What does that look like? Okay, so that's the graph we have there on the next page. And you will notice here that the 0 right here is not linear. You see how this is just like the one we just drew on the last example? It's linear. Okay, over here, ladies and gentlemen, this is not linear. It's curved like a parabola. And if we recall from Algebra 1, or actually a few lessons, or a lot of lessons ago, we actually revisited this topic, that if you have anything like x squared, x plus 1 to the second power, you can have x squared plus x, you can have x squared minus 1, whatever. If it's degree 2, and all of these have a second degree, by looking at the exponent, the highest value exponent. So a refresher, hey, a degree of a polynomial means what is the highest exponent? So these are all degree 2. And when you see that it's degree 2, the degree will determine the multiplicity at that factor. So if we'll say it's multiplicity of 2. So multiplicity of 2 gives you this shape here. So this is multiplicity. I'm going to abbreviate here. Multiplicity 2 gives you a curve. Multiplicity of 1, which we did in the last example, will give you a straight line. Okay. So multiplicity of 2, multiplicity of 1. Okay, so what the heck would multiplicity of 3 looks like? Well, if you recall, a degree 3 polynomial is called a cubic. And a cubic, you might have recalled me talking about the snake graph, because it looks like a snake. Okay, had to be careful, because right here, you'll see why I was careful here right now in a moment. So we have 2 zeros here. Okay. So right now, this would be a good chance for you to check your understanding. So what's the multiplicity here? The multiplicity is 1. And why is the multiplicity 1? Next question, right? Well, I came out to that conclusion because, ladies and gentlemen, this is linear. And when it's linear, you see the word line? That means it's degree 1. Don't worry, in a moment, I'll define degree 1, degree 2, degree 3 for you. So you have a nice chunk of information there for yourself. Okay, so here at this part of the graph, we have this shape. It's kind of like cubic, right? So this is cubic. I also call it snake. You definitely don't want to show up someone professional and say, oh, it's a snake graph. Don't do that. That's just between us. But it's cubic and it has a snake, which means it's degree 3. Which means it has multiplicity 3. Okay, so let's do a quick recap of the 3 types of multiplicities and the kind of graphs. So multiplicity 1 gives us linear. Multiplicity 2 gives us like this parabolic shape. I'm going to spell the word parabola so we can have practice with that. And then multiplicity 3, it's right next to us here. It's cubic by nature. All right, so we discussed the 3 types of multiplicities that we would be exposed to in this specific scenario, or rather in this lesson. Now, there are other multiplicities that we can go into. And if you want to dive ahead, I would love if someone in the class could shout, Mister, I'm going to go do research on multiplicity 4, 5, 6 and see what I find. That'll be music to my ears. But for all intents and purposes, let's go ahead and move on to some of the other stuff we need to remind ourselves about, because the cool down is a little heavy this week. So here's another concept we need to cover. Positive and negative functions. We've seen those where positive functions point upward, they're concave up. And then downward functions, which are negative, are called concave down. Okay, so what we're gonna do is we're actually gonna go way more in depth here in Algebra 2 than that, and it's this thing called end behavior. Okay, so get ready, buckle up, because this one's a little lengthy here. So it's called end behavior. And it's exactly what it sounds like. How does your function behave at the ends, at the tips, right? So let's go ahead and look at this function here. There we go. Okay. So first of all, this is always what your end behavior is going to look like. As x goes in the positive direction, and as x goes in the negative direction. And then that's this axis, right? So it's talking about when you're going to the right, what is your graph doing? When you're going to the left, what is your graph doing? Okay, so you might be wondering, well, what about the y-axis? Do we also talk about that with end behavior? Yes, end behavior is a combination of your horizontal and your vertical movements, which would cause diagonal movements if you add them together. Think about it like vectors in physics or wind, right? Wind, W-I-N-D, wind. So let's say your x is blowing this way and your y is blowing that way. Well, what you're actually going to get is a result. If you had a fan here, that's a fan, that's a horrible fan, and a fan here. Well, if you had one blowing this way, one blowing that way, then that means your object's going to go diagonally that way. This is the final result. So that's how we should think of end behavior. It's like, think about a fan. The x sends you horizontally, and the y, which I'll write down in a moment, will send you vertically. So let me write down the y. So if this means right, that means left. What do you think these two mean? Okay, so this one's gonna mean up, and this one's gonna mean down. So this is definitely a piece of information you want in your notes, okay? So this is called as x approaches positive infinity. And in the book, you're gonna see that they say as x gets larger and larger. Sorry. As x gets larger and larger in the positive direction. There we go. That's this right here. Now this one would be as x gets larger and larger in the negative direction. This is as y gets larger and larger in the positive direction. And this is as y gets larger and larger in the negative direction. Okay, so think about it this way, especially like, let's look at this one. As x gets larger and larger in the negative direction. Now I'm talking about this one right here. So as you get larger and larger in the negative direction. So let's say we start from here. We throw an object into the air. You see, my line kept getting larger and larger in the negative x direction. Now let me show you what y gets larger and larger in the negative direction. Okay, I'm gonna start from here again to erase that one. As y gets larger and larger in the negative direction. There you go. So you get larger and larger in the negative direction. -1, -2, -3, -4, -5. You see how it's getting larger in the negative direction. The negative values are getting larger and larger as we go down. All right, so let's go ahead now, put it all together. I could go over this one, but I think it'd make more sense at this point to just go into some examples. Okay, so this is what's gonna change on these problems. Okay, right here. So I'm actually gonna draw something that I have no idea. I'm just gonna throw it out there into the wild. Positive, negative, positive, negative. All right, let's see what I get out of this. Okay. I'm gonna draw whatever graph I want, doesn't matter, but right now what I'm trying to figure out is the end behavior. What do the arrows look like at the end? So it can be any function. I just wanna know, do the arrows point down? Do both of the arrows point up? Does the one on the left point down? The one on the right point down? Do they both point down? And these are the only 4 possible combinations you can have. Because end behavior says, how does it end on the left? How does it end on the right? So it can be down, up, 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 down, or down, down. Okay? And this, if you put these together, will let you know these things up here. So let's hop into it. Okay. So as x gets larger and larger in the positive direction, means I'm going right. I'm going to read these two together here. These two get read together. And I'm going to read these two together. This is what I found the best way to do this. Y is going up. So as right and up. Oh, okay. So I got this going on. So as x is getting larger in the positive direction, and y is getting larger in the positive direction, we have like this shape here. Okay. Here, let me show you a couple more, because some of you are wondering, does it have to be exactly like that? It can be like that. It can be like that. Okay. Any of those would work. As long as it's pointing right up, you are good to go. Okay. Now the next one over here is as x is getting larger and larger in the negative direction, y is getting larger and larger in the negative direction. So left and down combine those two together and you get this shape here. Like if it was wind, remember? Okay, so in the middle, I can actually put whatever I want because the question I asked didn't say draw a perfect graph. All it said was think about the end behavior. All right, let's do one more end behavior example, and then I'm gonna stop it here. And the next video will be a activity for processing video for you to actually now take the end behavior, take the multiplicity, and then apply it to the actual cooldown. I should not have erased those at the bottom, but it is what it is. What if I do them all negative? As x gets larger and larger in the negative direction, as x gets larger and larger in the, well, let's do this. Let's do this. Bless you. Let's do this one -2. I think this one's gonna be good. Yeah, that's good. All right, let's hop into it. I'm excited. Okay. So as we go to the right, our graph is going down. As we go to the right, our graph is going down. Cool. As we go to the left, our graph is also going down. And then whatever I want in between, that's up to me. There you go. All right, I'll see you in a bit.